Welcome, y'all. Back to some more geometry. Today we're talking about conditional statements. Let's see what conditional statements even mean. So conditional statements can be written in the form of if and then. Means there is a condition based on what's going on. So for example here, if the mouse steps on the trap, then the mouse trap will spring. Okay, so that's what's an if then. So this won't happen unless the condition is met. This is the condition over here. Now, if then are represented by P's and Q's, where P, the P statement, I'm going to put this in blue. This is our hypothesis. We're hypothesizing that if the mouse is on the trap, our conclusion will be the trap will spring. So you'll see this a lot. Now, this is the truth table for this equation. Just kind of talk about this. So, hey, so in the statement P and Q, the mouse stepped on the trap, okay? The trap sprung. So the whole statement as a whole together, the whole thing is true. So this right here can be read as if implies Q, then. If implies then. So if or P implies Q, or if implies then. So this happens, so this will happen. Now, let's take the same statement. Hey, let's say the mouse sits on the trap, but the trap did not spring. So the statement as a whole is false. Okay, but let's flip it. Let's say the mouse did not step on the trap, but our trap still went off. So the statement is still true in a sense because what we wanted, this is the reaction we wanted. We wanted this to happen. We wanted this reaction to happen. Because this still happened, even though this didn't happen, that means the whole statement is still true in general. And then if the mouse does not step on the trap and the trap does not spring, the statement is still true because this condition was never made, so this condition never had to happen. So because just this didn't happen and this didn't happen doesn't mean the statement is false because we never did try it out. So it's a lot to kind of comprehend conditional statements, but let's kind of go over one more time. So again, conditional statements are statements usually written in an if-then form, which says this has to happen, the condition has to happen for the reaction to go off. So let's kind of break that down a little bit more. So for example, if-then statement could be like this. If you live in Liberal, then you live in Kansas. Is that a true statement or a false statement? Okay, let's say you do live in Liberal. Hold on. Yes, let's say you do live in Liberal, but you don't live in Kansas. The whole statement is false. Yes, because how many liberals are there? I think there is 5 different liberals in the United States. So just because you live a liberal doesn't mean you live in Kansas. But let's say, let's flip it around. Let's say you live in Kansas. Do you necessarily live in liberal? No. Okay, so the statement is false. So hey, if it has feathers, then it's a bird. Okay, well, I have a pigeon. It has feathers. So that's true. Then it's a bird. True. There's not many things that have feathers. That's not a bird. Actually, I think that's one of the main reasons she had to be a bird. And for example, here's a math one related more to math. If 4x equals 20, then x equals 5. Is this a true statement? Yes, it is true. I put false on accident. Sorry, y'all. Let's erase that. It is a true statement. True statement. Now, if you are a runner, then you're an athlete. This is kind of more opinion based. I do think if you're a runner, if you're naturally a runner, then you're an athlete or athletic. But not all runners do it for a sport. But in the grand scheme, like how many people run? Not many people run except athletes. Cross country runners, you guys are athletes. Now, there are other statements that are based on this whole thing, this whole conditional statement thing. They're called relative conditionals, and we'll talk about those in a bit. But let's talk about one more thing here. So sometimes you got to convert. They're going to give you a statement and convert to if-then. So, for example, this statement says the measure of an acute angle is between 0 and 90. Okay, so we're turning this into a conditional statement. We'll say if if the angle is acute, then its measure is between 0 and 90. Okay, so let's kind of see how we did. So the measure of it's this kind of break down to kind of a English project right here. But what are the whole purpose of this statement right here is we're talking about an angle. Okay, so that kind of goes with our if statement. So we're talking about the angle. So this angle has to measure a certain amount to be considered acute. So if the angle is acute, so we know this is this, then the measure of it has to be between this. So most of these statements, you can just take the first half, make it a statement, and the second half will be your conditional. All right, but let's talk about converse. So there's your conditional statement. Your conditional statement is your original statement. So we just call it conditional. Your conditional is your original P implies Q. Okay, that's an original statement. A converse, what that does, it takes the original conditional statement and switches it. And then we make a new hypothesis based on that. So for example, if it has feathers, then it's a bird. That is a true statement right there. Let's flip it around. If it's a bird, then it has feathers. That is also a true statement right there. What about this conditional statement? 4x equals 20, then x equals 5. We said that it was true earlier. But if x equals 5, then 4x equals 20. That is still true. So converses, when we switch them, they will be relatively true still. They can be. But understand, some converse produce a false statement, as we said earlier. If you live in Liberal, let's say we're specifically talking about this town right here in Liberal. If you live in Liberal, then you live in Kansas. True. But let's switch it around. Say, if you live in Kansas, then you live in Liberal. That's not necessarily true. You can live in Holcomb. You can live in Garden. So this is a false statement. All right. Now, conditional statement. If you're a runner, then you're an athlete. We're going to say that's yes. But if you're an athlete, then you're a runner. No. Now, the way we prove these true false is that all we need is one example. For example, we need what's called a counter example. So if you live in Kansas, then you live in Liberal. False. What's my counter? So it's called counter example. Counter example. My counter example is I live in Garden City, we'll say. I don't. Garden City is kind of gross. All right. But if you're a runner, then you're an athlete. We can say that's true. But if you're an athlete, then you're a runner. Oh, that's false. Why? Because I am, let's say, counter example. So my counter example would be what? I am a wrestler. I'm a wrestler. We wrestle. I am a golfer. We golf. Drive our carts around. What other sports? Any other person that's not necessarily a runner, but they're still an athlete. These people are still athletes, but they're not runners. So that's some. Be mindful of that. Some converse produce false statements when you switch it around. Let's talk about inverse. So an inverse is where you take your original conditional statement. So remember, your conditional statement comes in the form P implies Q. We take our conditional statement and we negate it. So we're not necessarily saying we're going to make it a negative or not, but sometimes if it's already a negative and we negate it, we make it a positive. So for example, here, this is the conditional statement. If it has feathers, then it is a bird. Okay, true statement. Let's inverse that. If it doesn't have feathers, then it's not a bird. We're going to say that is true by nature. Sometimes some birds have like a weird condition where they have no feathers, they're just naked. But naturally, birds have feathers. So if it doesn't have feathers, then it's probably not a bird. Same thing with the conditional kind of like converse. There could be sometimes inverse will produce a false statement. And our last of the relative conditional statements is contrapositive. Contrapositive is not only a negation, but you also flip it. So remember, original, conditional. So conditionals come in the form of P implies Q. So we not only did we flip it, these two spots right here, we also negated them. So they flipped them and negated them. So the original statement is, if it has feathers, then it's a bird. We flipped it and put this statement over here and say, if it's not a bird, then it does not have feathers. Does not have feathers. So if it's not a bird, then it does not have feathers. Is that a true statement? We're going to say yes. Now, let's talk a little bit more specific. Biconditional statements. So biconditional statements are statements that are true forwards and backwards. You know, like a bicycle has two wheels, has to be true in two different ways. The original conditional statement and the converse. The reason it has to be true both ways is because we're saying P implies Q, that's true, and we're saying Q implies P, that's true. So no matter what way we say it, forwards or backwards, it is still true. So it's biconditional. It can be true in two different ways, forwards and backwards. Now, if you get a biconditional statement, meaning these two are true, then we make a new statement with what's called an if and only if statement. So for example, here, if points are collinear, then they lie on one point. The definition of collinear is they are on one line. Okay, well, if points are on one line, then they are collinear, because if you're all on the same line, you exist on the same one line, so you're collinear. So both statements are true regardless how you say it. So the biconditional statement for that will be points are collinear if and only if they lie on one line. So we take the original statement and we drop the if and the then, and we say, hey, points are collinear if and only if they lie on one line. Okay, so we get rid of our if and then and make it biconditional. Now, the last thing right here is logically equivalent things. So when making a truth table, so for example, let's go with the liberal. Uh, if you live in liberal, then live in Kansas. You live in Kansas. Okay, so we're going to take this statement right here and we're going to make a truth table for it. So we're going to do our conditional statement. Our original P implies our conditional statement, meaning P implies Q. So if you live in liberal Kansas, so this particular liberal, then you live in Kansas, that is true. Okay, let's look at the converse. Just flip it. Q implies P. If you live in Kansas, do you live in liberal? Not necessarily. So that's false. Okay, let's look at the negation. If you don't live in liberal, then you don't live in Kansas. So not P implies not Q's. So if you do not live in liberal, you don't live in Kansas, that's false. Just because you don't live here, that's false. I put a true. Sorry about that. That's false. Just because you don't live in liberal does not mean you don't live in Kansas. So that is false. And then our last one are contrapositive. So we negate them and we flip them. So not Q. If you don't live in Kansas, then you don't live in liberal. So again, we're assuming our liberal is the only liberal that exists. So if you do not live in Kansas, then you do not live in liberal. That is a true statement. So logically equivalent statement, meaning they have the same true value. So conditional statements, our original statement, P implies Q, will have the same truth value as our contrapositive. So this is conditional, a converse, an inverse, and then our contrapositive. Positive. The conditional statement, the original statement, will have the same truth value as the contrapositive, and then the converse and the inverse will have the same truth value. Either both be true or they both be false. So the last three problems in your homework, you're going to have to write the conditional statement, the converse, the inverse, and the contrast positive. You're going to write those statements. Are you going to tell me true or false? If it's false, give me a counterexample. And if it's true, then just write true. To double check to make sure your true values are true, statements are all true, double check, make sure that these two have the same value. So either they're both false or they're both true, or these are both true or they're both false. Okay, that has to happen. All right, y'all, have a great day. Hopefully that helps. If you need any questions, please let me know. Bye.